Hi, I'm John Ambrose. Welcome to our L2 lateral line training facility, where we'd like to present to you an updated version of the L2 lateral line training system. Keep in mind as you watch this video that although this is the simplest way to putt a golf ball, it may not be the easiest at first. The L2 putter and the lateral line system will not work for you. You must work for the system. By simplifying the putting motion, you will be relinquishing control to the L2 putter and instead become its guide rather than its manipulator. The simplicity and repeatability of a mechanized pendulum stroke is without question the best way to putt a golf ball. So sit back and enjoy watching this revolutionary USGA conforming way to putt and see why wanting different results will mean trying something different. I refer to the L2 pendulum as the inventor of the lateral line stroke because I simply copied all of its attributes. By building a machine that would do the best job of stroking the L2 putter, I was able to simplify the motion and thereby make it into a style that can be humanly possible to copy. When looking at the conventional stroke, you can see that in order to make a machine with the capability of duplicating this style means adding bends, angles, and joints. Having this predetermined motion in place and then trying to build a machine to copy it means limiting design options. These limiting options simply cannot be duplicated by us, so the resulting machine mechanics necessary to reproduce a conventional stroke that has the pendulum characteristics are not transferable back to the human motion. The L2 pendulum machine was designed to be the best way to take advantage of the L2 putter's characteristics, with the only restriction in design being to conform to USGA rules. What the L2 pendulum machine gives us is simple movement that we can copy thanks to the face-forward stance and a longer putter. The perfect motion of the L2 pendulum is repeatable and dependable. It doesn't second-guess distance or direction. If properly oiled, the motion is smooth time after time and never gets the yips. Although we may not be able to putt like a machine, we should at least try to emulate one when it comes to mechanics. Judgment, touch, and feel may be necessary human qualities for green reading and energy input, but it is in the mechanics and the unaffected repeatability that the machine outshines us. In order to incorporate these machine-like characteristics into our stroke, we developed the L2 pendulum to give us a motion that we could actually duplicate. The concept is simple. We read the green, aim the L2 pendulum down the aim line, decide how much energy to transfer into the ball in order to move it to the cup, and then apply this energy with backstroke size, releasing it and allowing gravity to generate the energy and allow the physics of the motion to do the rest. The combination of the L2 putter and the L2 pendulum machine has led to what I believe to be the best way to putt a ball, which I call the lateral line system. Stability and smoothness of motion are requirements the pendulum machine must meet, just like they would be in your stroke. If the pendulum machine was unstable or the swivel point not secure, the smoothness of motion and tempo would become distorted, producing an inconsistency in both distance and direction. Whether you're using a pendulum machine, a lateral line stroke, or any other method, in order to initiate the action, some outside force will be required. Muscle power and some joint movement is needed to bring a putter to the desired backstroke size in order to initiate the motion. However, if this muscle energy is only used for taking the club away from the ball, its effects on the forward action could be reduced. This does not mean that there is a possibility for error. If the backstroke movement is not done with the correct tempo in mind, or the correct amount of backstroke size, then distance can be distorted. Upon reaching the top of the backstroke, gravity and momentum do the rest by transferring the desired energy to the ball as the club seeks an equilibrium or neutral point while maintaining a constant tempo as it does. This neutral point is the point at which the motion started at address. This is why we do not hold the follow-through with a gravity-fed pendulum motion. To do so would mean we are forcing the club through the ball and adding to the momentum in anticipation of stopping the club at the finish. If the shaft of this putter were at a 90-degree lie angle, gravity would also aid in maintaining direction for the stroke. But because of the 80-degree lie angle that is required by the USGA, there needs to be a swinging support bar placed on the pendulum that extends out to the shaft in order to maintain the lie angle and keep the putter head square over the ground throughout the stroke as it freely moves with the motion of the gravity swing. The little fork that supports the shaft is what allows us to have a perfect pendulum motion even though the shaft is not vertical or 90 degrees. This support keeps the head over the aim line and the face square throughout the stroke. The lie angle support and single swivel point are the two most important parts of the L2 pendulum and the lateral line stroke. The tempo of a pendulum is based on the length of its swinging arm or radius. As this pertains to golf, we would say that the longer the club, the slower the tempo, as it is moved by gravity from a fixed point. Minus any outside influences such as wind, wobble, or human input, the pendulum tempo will be the same no matter how big or small the stroke size. But what is also interesting is this tempo will also be the same no matter how heavy or light the object attached to the end of it may be. To better explain this, if we were to take a tennis ball tied to a 20-foot rope and secured the other end to a fixed point, the ball, when pulled back to any distance and released, will travel at a tempo of, say, 50 beats per minute. If we now took a 20-foot cable and connected a 10-ton wrecking ball to it and pulled it back to any distance and released it, it too will travel at a constant 50 beats per minute. But if we were to place a wall in the way of both objects, the tennis ball would bounce off while the wrecking ball would go through it. While they travel at the same tempo, their momentum is significantly different. The tempo of a L2 pendulum with a 48-inch putter attached to it swings at 58 beats per minute. Even though a lighter conventional putter of the same length would swing at the same tempo, the heavier L2 head, unlike the lighter head, will be capable of displacing a golf ball a longer distance without the need to add any energy. The heavier the head, the greater the momentum. A lightweight 48-inch putter with a backstroke size of 1 foot may move a ball 10 feet. A heavy-headed putter with the same backstroke size may move a ball 20 feet using the same tempo. So in order to compensate for lack of momentum that comes with the lighter putter, some outside force of energy will be required to make up the difference. This means muscle and joint power. This need for muscle energy gets even bigger when the distance required increases and the backstroke size becomes limited.